Welcome everyone. Are we having a good PyCon? Yay! Cool. So I'm going to talk about what I personally think is the coolest feature in Python 3.14 and what you can build on top of it. I'm going to try and keep this higher level, but I'm also going to show like a bit of a case study and tool that I built to hopefully make this feel a bit more real. I built this tool that makes basically debugging containerized applications way less painful. Okay, a quick, brief intro about me. So I've been writing Python for about 12 years now. I started contributing to CPython in 2023, and I became a core dev in 2024. I am also currently on the steering council this year, which is like the largest honor ever, and I am the release manager for the upcoming Python 3.16 and 3.17. My day job is at FastAPI Labs, where we are building the very best Python cloud for your FastAPI applications. I also work on some open source stuff over there as well. But more importantly than like all of that is just that I am someone who likes to tinker with things and hack on things. So when I see like a new API or a new protocol, I just kind of have to poke at it. And so when I saw the remote debugging attachment protocol and sys remote exec land in 3.14, I could not help myself, and that's what brought me to this talk. Hopefully that's relatable for some of you. So I want to start with a bit of a problem, and I think a lot of us, if you've worked in like web development or with containers, I want to be kind of specific here. I'm not talking about debugging applications in general. I'm talking about debugging something that's already running in a container where you can't just drop a breakpoint and hit F5. And a quick note, maybe before I get too in the weeds, I'm going to say the word Kubernetes a couple times in this talk. I'm sorry. If you haven't used Kubernetes before, it's just a container orchestration system, basically a way to run and manage containerized apps. In this context, I'm going to be talking about using it for local development, so you can think of something like Minikube or like Tilt, if you've heard of those things. But the key concept you're going to hear me talk about is a pod, and you can just think of a pod as a running container, or maybe like a small group of containers that live together. Everything I'm going to describe works with plain Docker or Podman too, so if you are too triggered by Kubernetes, don't worry about it, it's okay. But okay, so like let's say we have our FastAPI application running locally in a container, and something is wrong. Maybe like a request is hanging, or there's a memory leak, or there's an async task that's silently failing, or maybe the bug only shows up under load or when the service has been running for a while, or a specific sequence of events or requests that you haven't been able to fully reproduce. So like normally we'd like, if we weren't in a container, we'd like smash F5 and then like it would be good, we'd have a debugger. But like we're in a container, so like what do we do here? Well, like we can restart the container. We could like just restart it and nuke the state, but like that state is now gone, and that half full queue or that stuck coroutine or whatever was accumulating is gone, and so like we can't debug what we can't observe. Our second option is perhaps to spin up a debug sidecar. This is maybe what I would affectionately call a side quest, mainly because you probably weren't trying to set up infrastructure, and like, yeah, we can set up a second container alongside the app that's wired up for debugging, and that just works. But like, again, kind of peripheral to the task, and maybe you've been subjected to using containers or Kubernetes for your local development, and so like this kind of takes away from like the time that you want to spend on your application. Another option is add more logging or print and pray, and that's, we've all been there, no shade. But like we can add a statement and restart and reproduce the bug and like maybe realize we logged the wrong thing, and then do it again and again. And for like async race conditions or like stateful issues, you often can't add enough logs for it to actually see what's happening. And so like none of these really let you inspect a running process without interrupting it, and this is kind of the gap that we have. And so like what I wanted was just to attach a real debugger to a live process. I didn't want to restart my app. I don't want to change my application code. I don't really want to go on infrastructure side quests, although I kind of went on one here to build the thing that I'm going to talk about. But I want breakpoints, I want variable inspection, I want the whole 9 yards. I want like a debugger experience. And Python never really had a native way to do this, but that's actually what landed in Python 3.14. So I want to talk about sys remote exec and how it works under the hood, and also why it's safe. Because, I don't know, maybe remote exec sounds sketchy. But I think understanding the mechanism here is important because it's like not magical and it isn't sketchy. So like, what is sys remote exec? I would say the API is like deceptively simple, but like maybe not deceptively simple because it is actually quite simple. It's just kind of implemented in a really clever way that I grew a really deep appreciation for. And so basically we have this API we can call sys_remote_exec with a PID or a process identifier and a path to a Python script. And that's it. We can execute code in a running interpreter. But what happens when you call it is kind of interesting. So the script that you point at gets executed inside the target process. It runs in a fresh scope, but it has access to everything via imports. Any module your app is imported, you can import it to and get the live running version. So if you have a FastAPI app that has a database connection pool somewhere, you can import that module and you're holding the live actual pool, the one that your app is actually using. Any cache, global state, it's all accessible. The target also doesn't need to be restarted. You're attaching to a process that's already running with all the state that's accumulated since it started, which is kind of the whole point, right? And the target also doesn't need any preparation either. We didn't need to know ahead of time that we wanted to use sys_remote_exec when we actually want to execute it. You don't even need to import any library or module. The only requirement is that you're running Python 3.14 or later. And then finally, this builds on this remote debugging attachment protocol under the hood, which was introduced with PEP 768, and that's what landed in Python 3.14. So that's the what. But let's look at how this actually works, because this is, I think, just brilliant and super cool. Okay, so a quick primer on how your Python code runs, if there's anyone in here that doesn't know. I'm not going to go super in depth on this because there are like 1 million other PyCon talks that have been given on this topic. So I'm sure there are more in-depth ones that you could watch online. But like for the premise of this talk, the important bit to know is that when your code is run, it's not run directly. We compile your code down into bytecode, and these are like small instructions that the interpreter runs in a loop. And that's like the eval loop on the right that evaluates them kind of like one by one. The important bit here is that at regular save points in the bytecode loop, the interpreter does a tiny check called the eval breaker. We can just think of this for all intents and purposes as like we need to do housekeeping. So things like garbage collection, handling signals, handing off the GIL. If nothing's pending, then it just keeps going. But when you call sys_remote_exec from the outside, all it does is leave a note. It says, it writes your script's path into the target memory and then flips the eval breaker flag to wake up the thread. This is actually why it's safe. The interpreter only notices the flag at those safe points, never in the middle of an instruction. So your script runs when the interpreter is in a consistent state, when nothing is like half done or mid-allocation. Comparing this to maybe like older tools like Parasite, which you would attach a debugger and interrupt the process at a random point in its C code. And it does understand the GIL, but like it's less safe and it happens at a higher level. This is happening at the bytecode level, which makes it a lot safer. And that's really the difference here. At the save point, the interpreter runs the script and then picks up where it left off as if nothing had happened. If your script throws, then the exception gets logged and the app will keep running and the target process won't crash. And so that's really okay, we are advancing, good. And if you want to go like deeper on this, there was a talk at PyCon last year by Pablo and Ivona, and it walks through the whole implementation in a lot more depth, and it was truly excellent. I have a bunch of links at the end and a QR code which you can scan to grab them, but you should absolutely watch that talk. Okay, cool. So now we have this primitive, right? We can run code inside of a live process thanks to sys_remote_exec. It's also worth mentioning, because I'm talking about debuggers, that in 3.14, we also added PDB attach with a PID argument that uses sys_remote_exec under the hood to drop you into an interactive PDB session. But I wanted a full editor debugging experience. And for that, we need to talk a little bit about DAP. So DAP is the Debug Adapter Protocol. It's a standardized JSON protocol that defines how editors talk to debuggers. Microsoft made this for VS Code, and then like everyone else kind of picked it up. So if you use like PyCharm and like NeoVim, Emacs, they all kind of have DAP compatibility. And so if you speak DAP, you kind of work with like most editors out there. But the important bit about DAP is that it has an attach mode. DAP lets you connect to a process that's already running, not start this process with the debugger attached, connect to one that's already going, and that's the mode we care about. Through that connection, you get everything. You get breakpoints, stepping, watches, call stacks, the whole 9 yards, a full debugging experience. But the piece that ties it together for us is a thing called debugpy, which is really an Python implementation of this adapter. It also can be started from inside of a running process. It's just a Python module you can import and call debugpy listen, and it starts up a debugpy server, and it doesn't have to be there when the process starts. So if you're, I don't know, the recipe's sort of coming together here, but like you can use sys remote exec to inject a script that imports debugpy and calls listen and then point your editor at it to get this experience working end to end. The process never has to stop. You don't have to change any code. You don't have to restart anything. And like when I got this like working, or at least like realized that all these pieces were like compatible in the way that my brain wanted them to be compatible in, I was like really excited. And so I kind of went into a hole and like started hacking away on this. And at this point, maybe you're like me and you're like, that's so cool. Or maybe you're like, that sounds like a security nightmare. And so like both of these things are valid, but I do want to take a second to talk about like the second bit there. Okay, so execute code in a running process. That sounds maybe bad. And I'm specific, I hesitated to add this slide, but I did because every time I talk about sys remote exec online or in any social media context, I get accused of trying to Trojan horse someone. And so I like really wanted to highlight this is like, has like a really thoughtful and robust security model that I think is just really great. And so this isn't some kind of new attack surface. Like sys remote exec needs the same operating level permissions that any debugger needs, the same gates that something like GDB has to go through. The caller also has to be the same user as the target process, and you can't like just reach into someone else's Python code from your own. It's not possible. The other thing is that in order to be able to use sys remote exec, the platform has to have the different capabilities enabled. So in containers, like if you're using a Linux container, you're gonna have to enable like sysptrace, Windows, Mac, they all have kind of equivalents. If you don't have this enabled, it'll just error out, and that's on purpose. Also, nothing is attaching automatically. You have to run the command, you have to initiate the connection. There's like no listener or daemon. And like perhaps like my favorite of kind of the like security angle of this is that the script that you point at has to be a real file on disk and not just like a string you pass in. And that sounds kind of like a limitation, but it's actually a security feature. Python has audit hooks, which is a system that lets you log and block sensitive operations. So every call that you make to sys remote exec fires an audit event with a script path. And so does the target before the script actually runs. And so if you want to lock this down further, you could, I don't know, like wire up a hook that allows you to only run scripts from a specific directory or block it entirely. And on that note, there's like many flavors of turning this off completely. There's an environment variable, a command line flag, a build time configure option, pick your poison. And so like those are like many different dimensions of this threat model or like the security model of this. But like really, if someone has enough access to your machine to attach the debugger to the process, they already have code execution. And so the debugger interface is like kind of way down the list of concerns at that point, and like the call is maybe coming from inside the house. And so you should just treat sys remote exec for what it is, which is a debugger, and you, I think, don't need to be worried about using it in local development. If you're trying to use it in like prod, like maybe don't enable like sysptrace or like these capabilities unless you like need them and like know why you need them. But okay, like I've given like a big spiel on this, but like we have this primitive, right? That we can execute code in a live running process. We have DAP to talk to debuggers and debugpy, which lets us inject. And that's actually all the pieces that we need to build something pretty cool. So I took this idea and I turned it into a tool that I call debugwand. It's really just a CLI that wraps a bunch of complexity, like discovering containers, finding the right process, injecting debugpy, setting up port forwarding into a single command. It works with both Kubernetes and Docker or Podman. And I want to talk a bit about how it works, mainly to hopefully, like, I don't know, get your creative juices running and like inspire you to maybe think about how you can continue to like extend these types of experiences. So I guess this is like kind of a meta point, but like again, coming back to the goal here, the goal is to make it feel like I'm not in a container or working with containers. Security, isolation, these things are usually at odds with usability and overall developer experience. And so for this, I wanted to be able to smash F5 and be able to debug my app that's running in my local Kubernetes cluster. I wanted one command and we're debugging. So with the CLI that I built, you run wand debug with your namespace and your service name. And if you work with Kubernetes, these are familiar constructs. But that's it. But what happens when we run this is that we go off and we find the right process, we inject debugpy into it, and then set up port forwarding, all in a few seconds. It also works with Docker, so you can do wand debug -- container, my container name, same flow, except for it's using Docker or podman exec under the hood instead of kubectl. It also supports Knative, and I mentioned this from a tooling perspective, mainly because Knative's serverless platform built on top of Kubernetes, where services automatically scale down to 0 when they're idle, which makes building tools like this sort of tricky because if no one's hit your service recently, there's no pod to attach to. And so building developer experience, detecting this and telling you what's going on instead of silently failing. The only requirements here that you need, Python 3.14 in the container, debugpy installed, although maybe that's vendorable in the future, I don't know. And then sys ptrace capability granted on the container, and those are the only prereqs. I don't really consider those application code changes. Those are more configuration changes, and so these are all things that are pretty lightweight and easy to check into the repo. So we run this command in one terminal, and then separately, to connect the editor, we add a standard debugpy attached configuration pointed at the default port or whatever port you want. This is the same configuration you would use for any debugpy attached session. So if you're familiar with VS Code and launch.json, there's nothing special about this. This is just a very plain configuration file. Once you hit start debugging in your editor, we are live and we have all of the features that we're familiar with on a process that was already running when we decided to debug it. But what's really cool about this is that, so at work we use this and we set it up as a tilt resource that comes up with the rest of the cluster. So we actually never run wand debug with our namespace. We set it up as a resource, it spins up, and then we checked in the launch.json into our repo. And so we just get to smash F5 and never think about the fact that we're working in Kubernetes when we're trying to debug application code. So that's pretty cool. But what's actually happening under the hood here? So a quick reminder, if Kubernetes isn't your day-to-day, I am gonna have kubectl commands on this slide, but really the things you need to know, they're just 3 commands. One's for copying files into a pod, one's for executing them, and one's just for establishing port forwarding from inside the pod out to your local machine. So when I run wand debug, debugwand goes off and kubectl copies 2 small scripts into the pod. One's an attacher.py and one's a debugpy script. The reason these are separate is also because I've designed it in such a way that we can run arbitrary scripts, not just debugpy inside the container without having to go and fuss with a bunch of Kubernetes to make that possible with a command called wand inject, so you can execute arbitrary scripts as well. But anyway, once we have those copied, then kubectl exec runs the attacher inside the pod. It has to run in the pod because sysremote exec needs to be a local call. You can't reach into the container from the process from outside of it. The attacher calls sysremote exec with the target PID. And this is where everything kind of kicks in. The script path gets written to memory. We set eval breaker flag. The interpreter picks it up at the next save point. And then the debugpy script goes off and it executes inside the app's process. It starts a debugpy server on our default port or whatever was specified, and the app never stops. Debugpy will just spin up in a new thread in the same process. Debugwand also then goes off and sets up kubectl port forward to port forward back out to my local machine, and the editor can connect over DAP. And there it is. When you run this, then we can hit breakpoints on a process that was already running. No restarts, no redeploy, no sidecars. It just works as if we didn't have a container in the way. Yay, yay. But before I wrap up, I think there's just a few more, I don't know, I want to call them gotchas, but maybe just things to know if you're maybe thinking about building tooling on top of this. And these aren't tool-specific problems, but maybe the realities of how Python applications are structured. And how attaching to a running process works. They're just sort of usability hurdles that you need to think about. So like one that maybe surprises some people is that your app is also often not a single Python process. And maybe that's obvious to some, but if you run something like uvicorn with reload, you'll get two processes. You'll get one that's a watcher and one that's a worker. The watcher will monitor the files and manage the worker, and the worker is the actual one that's like handling all the requests coming in. Gunicorn does something similar with like a master and a worker pool. Multiprocessing spawns helpers like a resource tracker. And so if you want to attach a debugger to the right process, you have to know this. If watching the watcher, attaching to the watcher is useless because it doesn't run the request handler, attaching to the resource tracker will also be useless and tell you nothing, so you'll want the worker. This applies whether you're using like sysremote_exec or GDB or anything where you're trying to touch processes. In this tool in particular, I chose to handle this using heuristics. So I just filter to known helpers with different command line patterns. So like you're looking for uvicorn or FastAPI run or gunicorn, auto-selecting if it's unambiguous, and then prompting if it's not. Whatever tool you might build on top of this is kind of logic you might need to think about. I guess like spiritually, I would say uvicorn with reload just like made my life hard. Reason being is like uvicorn reload is an amazing developer experience when you're iterating. It's like automatically watching files and restarting the worker on save, so you don't have to like continue to restart things manually. But the thing that maybe you won't think about is that when the worker restarts, it also gets a completely new PID. So if you attach a debugger to PID 11 and then you save a file, uvicorn will kill that PID and restart a new worker on some other PID that you know will never have heard of. Well, your debug session will die, and then it'll never have heard of debugpy, and then like it just won't work, which sort of sucks. One way to handle this is just like auto detecting this mode up front, and then monitoring the worker PID in the background and re-injecting when it changes. The worker will restart in this case, which is like a little bit of friction, and the debugger will disconnect. But because all the breakpoints are set up on, or like stored on the front end of the editor, you don't lose any like kind of like debugging. It's just, you know, one extra click. Okay, but let me wrap up a little bit here because we're getting close to the end. So sysremote_exec is one of those features that I think changes what we think is possible with Python. Executing code in a process that's already running without any preparation is like genuinely really cool to me. Pairing it with debugpy and DAP and building like a full debugger experience in a running container in seconds is really cool. No restarts, no code changes, getting like the developer experience that we're used to. I think it's also worth saying that debugging is my use case, and yes, like the protocol is called like remote debugging attachment protocol, but the primitive is actually quite general. Like if you want to do hot configuration changes or state inspection or one-off investigation scripts, anytime you want to look at a process without restarting it, I think this should be something maybe you consider part of your toolbox. So I'm interested to see what you will build with sysremote_exec or what value you derive from it. I built debugwand because I wanted a debugger that could attach to a FastAPI app pod in my local cluster, but that's obviously one application of the primitive. There's also a lot more. Debugwand is also open source if you want to like try it or fork it or build on top of it. If you build something cool, I would really love to hear about it. One more note, so I mentioned that I work on FastAPI Cloud. A lot of what I'm showing here today is stuff that we're building into FastAPI Cloud. If that sounds interesting to you, no pressure, but we can get you into the private beta and you can play around with it. This will just fast track you on the list. I'll also have a link to the slides on the next slide. So I'll pause for a second because some people are taking pictures, but there's no pressure because there's another slide after this. Okay, and finally, here are some links if you want to dig deeper. The Python docs have a really good how-to or like docs on the remote debugging attachment protocol at like a lower level, walking you through kind of the whole attachment mechanism at a like in depth. Debugpy's GitHub has documentation on the tool and also DAP. Debugwand again is on GitHub and PyPI, so you can install it with UV-tool install debugwand. I also wrote a blog post on this earlier this year that goes into more detail on the whole topic. Finally, and I'm not sure if any of them are in this room because Pablo's talk is on the other side of the ballroom, but I want to give a shout out to Pablo, Ivona, and Matt who worked on co-authoring PEP 768 and this whole protocol. I am like super jazzed about this addition to Python, and so if you think this is cool and you find it useful, they're all here at PyCon this week and you should absolutely thank them. Oh, and finally, not related to this talk, I recently started a core development newsletter called Core Dispatch. If you want to check it out, you think core development's cool, you want to know more about what's coming to Python, you can check it out at coredispatch.xyz. And with that, thank you so much, and I will be around for questions in the hallway. Come find me.